Hey everybody, it's Mr. Carr again. Today we're going to be talking about 9.2 day 2. We're going to be looking still at parabolas. Okay, I'm going to go right to the example, but now we're going to talk about using information to help us write the equation now. Okay, so in this case, we want to write an equation for a parabola with a vertex at 0, 0 and a focus at 0, -3. So it helps if we kind of follow these steps here. Let's start with plotting, because in the event we know we need a graph in the end, might as well just plot what we have. So here's my vertex. And here's my focus, okay? Determine which way the parabola opens, then write the appropriate equation. So we know that with a focus, it has to go towards it like that, okay? So it opens down. So we're dealing with like a y equals a negative x squared scenario. But I can be more specific. It's actually going to be this. It's going to be a negative 1 over 4p x squared, okay? So remember what p is from. It's the length of this right here, okay? So that's 1, 2, 3. So that in that case, p equals a -3 here. So I can take 1 over 4 times a -3 gives me 1 over a -12. All right. So that means that is my a value. Okay. So I can set that up now with it being 0, 0 as my vertex. It's just going to be y equals -1 over 12 x squared. Okay. And the last thing I could do to help plot this for the graphing purposes, since my focus is at the point 0, -3, I know that my lattice rectum has to also have y values of -3. So I could do this, where I say -3 equal to -1 over 12 x squared. So I multiply both sides by a -12. So I get a positive 36 equals x squared. Okay. And then I square root both sides. I get plus or minus 6 for my x value. So again, what this means is my lattice rectum has 2 points. It is going to be the point 6, -3, and -6, -3. Okay. So from here, I'm going to go, what's here? 1, 2, 3, 4, 5, 6, and -3 here. 1, 2, 3, 4, 5, 6, and -3 there. Okay. So again, the idea today is we're going to use the information, some incomplete information, to still get our equation if we use it to find our missing, basically the a value. All right. And for most parts, we're going to just focus on when the vertex is at 0, 0. Okay. Here, write an equation for parabola with a directrix x equals 2. So let me plot that information. And a focus at -2. Okay. So again, what we know for a fact is it's going to open something like this. Okay. The vertex we know is it right in the middle of the directrix and the vertex. So it's going to be 0, 0. So my vertex is at 0, 0. I'm also going to be dealing with, not y equals, it's going to be x equals y squared is my scenario. Okay. The p value here, because it's opening to the left, is going to be a -2. So that means my equation I can do 1 over 4 times a -2, which gives me 1 over -8. Okay. So that means that my equation is going to be x equals -1 over 8 y squared. And again, because my vertex is at 0, 0, I don't have to worry about doing a number inside parentheses and a number afterwards. Okay. So there's my equation right there. The last thing I want to do to help graph this, well, actually, I mean, technically the directions are done. I've got everything I need, but if I did want to graph it, same thing as before, let's find the 2 endpoints for the lattice rectum. Okay, so my focus is at -2, 0. So that means that -2 equals x. We're going to figure out when that happens in this case. Okay, so I multiply both sides by a -8 to cancel that out. -8 there, so I get positive 16 equals y squared. And then I square both sides, I get plus or minus 4 for y. So that means my lattice rectum is at the points the -2, 4 and positive or -2, -4. So -2, 1, 2, 3, 4 up here. Then 1, 2, 3, 4 down here. Okay. All right. And last example, let's talk about a word problem. The Hume Arch Bridge in Manchester, England, is supported by cables suspended from a parabolic steel arch. The highest point of the arch is 25 meters above the bridge, and the focus of the arch is about 18 meters above the bridge. Let the bridge be the x-axis, and let the y-axis pass through the vertex of the arch. And we want to write an equation that models it. When I look at a problem like this, I like to just do a quick drawing of it to model it out. So the idea is this: I have here's the arch, and then here's the bridge. Okay. So what we know is we're going to have the vertex right here. We're passing through the vertex with the y-axis, and then this is the x-axis here. That is the bridge. The highest point is right here. So if I model that as a point, it says 25 meters above is the point 025. Okay. The focus is 18 meters above. So modeling it, it's about right here. It's 18. Okay. So if I want to write it as a point, it's the point 018 for the focus. But the thing to remember about the focus is that the distance to go from there to the vertex, that is the actual p-value. So in this case, that's 7. Okay, so I could do a little bit more algebra, but I'm just going to go off my model here. P is going to equal to, and especially, and in this case, a -7, because of the fact that it's opening down. So I actually have enough to do my setup here. Because it opens down, I'm going to use the 1/4px². I should say x minus h² plus k. So here's a case where my vertex is not at 0, 0. Okay, but I'm still modeling it. Excuse me. I'm still modeling it pretty similarly. The h value here is going to be 0 because the vertex is passing through the 0, but my k is 25. So y equals 1/4 times -7 times x² plus 25. So I can multiply through and just simplify a little bit here. So y is equal to a -1/28 x² plus 25. Okay, and so that's just an example where we can move our vertex off of the origin and just make it a little bit trickier, but it's still the same concept. We need to know how far away is the focus from the vertex. That's my p-value, and I can use that in my model right here. Okay, then the k value is just the part of that vertex right there, and that's it. Okay, all right, that's it for 9.2 day 2. Take care, everybody.